Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, structure and bonding. So how do we identify which compounds are ionic and which are covalent? So just to remember really that ionic bonds are formed when you have metals reacting with non-metals and you have that electrons being transferred between those two things. And covalent bonds are when I have non-metals bonding to other non-metals, and that's where we have are pairs of electrons being shared. So how do we identify which substances have giant structures and which have simple structures? Well, for ionic and metallic, it's relatively straightforward because those are always giant lattice structures. For covalent, it's a little more tricky, and you have to really look at the properties of the substance to make a decision. So, for example, you could look at their boiling point, and if it has a very high boiling point, then it is a giant structure, or if it has a low boiling point, it's a simple structure. Maybe you could look at conductivity or solubility as well. So it's possible you might have to do that, and do check out that table in the notes because that summarizes all of these properties really well. Or perhaps it's an example that you actually need to know. So that would be diamond, graphite, graphene, and for some of you doing AQA or IGCSE AQA, silica as well. Okay, we need to use the table below to identify the structure and bonding of each of these substances. So we're choosing between here for my bonding, is it ionic, is it metallic, or is it covalent? And then the structure we're talking about, is it giant lattice structure or is it simple molecular structure? So let's have a look at this first one here, A, and I've noticed straight away that that melting point is low. And there is only one combination of structure and bonding that is true for, and that is simple covalent, that we have this low melting point. So that must be for substance A. Substance B, a little bit trickier, but my eye's drawn to those two pieces of information there. So we have that it does not conduct when it is a solid, but it does conduct when it is a liquid. And that leads me to think that it is ionic in terms of the bonding, and it must be giant ionic lattice because ionic doesn't have simple structure. And so how do I know it's that? Well, remember that when you have your ionic compounds as a liquid, what you have is those ions are actually now free to move. So that means that it actually conducts electricity when it's a liquid. Okay, part C here. So I've got no and no to it conducting when solid and liquid, and it's got a high melting point. So what I'm saying is it can't be simple covalent or ionic. It can't be simple covalent because it has a high melting point, and it can't be ionic because otherwise it would conduct electricity when it was in liquid form. So it doesn't actually conduct electricity at all, so it's also not going to be metallic. So therefore, I'm left with giant covalent, giant for my structure and covalent for my bonding. And then for part D here, well, I've kind of got two choices really, because only metals and graphite will conduct electricity as a solid, and it tells me here that this does conduct electricity as a solid. So my best guess really is to assume that it's not an exception to the rule and going to be my graphite, and instead it's a giant metallic structure. Okay, so we have different models to represent some of this bonding, and what information can we take from each model and some limitations as well for these models. So this first one here, we do get the information of what the ratio is of carbon to hydrogen here in a ratio of 1 to 4, but what we don't get is we don't get shown the type of bonding that's going on here, and we also don't get shown what kind of shape the molecule is. In part B, we do have our dots and crosses, so we can tell that it is now covalent bonding through those shared pairs of electrons, okay? But actually what B and C don't show you, so the stick diagram C is as well here, which is showing those covalent bonds as sticks, is they don't show you the shape because they're not 3D, okay? Whereas model D and E here, so we've got the ball and stick and this space filling E, both do show the arrangement of those atoms in 3D space, and E as well shows you the relative size of each of these different atoms.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Tips and tricks for this section. So the first one is we're kind of working as a process of elimination here when we're looking at structure and bonding. So for example, if you know it's not covalent and you know it's not ionic, then you can come to the conclusion that it must be metallic. So it's not always obvious which one it is, but by eliminating the others, then you may be able to tell. And you need to make sure that you do know the examples of the giant covalent structures that are all in your notes, because then what that will do is it means you can be more confident at identifying simple covalent molecules, okay? Because it's sometimes hard to know whether it's going to be giant or whether it's going to be simple, and knowing all of those examples might help you there.